Okay. So we were object detection team Auto Magic. It's team members me, Sonu, who will speak on some of the stuff he worked on. Mukesh has an exam tomorrow, so I don't think he's on the call. So here's our project, our task. We were tasked with creating an object detection model that was capable of identifying objects on roads, and especially vehicles that were unique to Indian roads. Our data we sourced from a 7-minute and 30-second video of a car driving through various roads in India. And we used, the video was 30 frames per second. We extracted 3 frames from each second at index 0, 10, and 20. So we had a good variety of frames from the video. So then we annotated, which we've talked about, and I think Rosen will speak more on that. But here's some things we learned from annotation. Number one, the Tensorflow model we were using just draws bounding boxes, so rectangles were all we needed to do there. It's really important that you have consistency across the group when we have multiple individuals annotating. Taking a look yesterday, we realized there was some spelling errors and just people identifying things as different things. So we had early on agreed that motorbike, car, truck, person, auto, bus, animal, tractor, and then poles, if we had time, that was something we were going to work on later. So these other ones we needed to fix, and Sonu actually wrote a nice script for fixing those. So Sonu was on to set up our Google Cloud Storage bucket, so I'm going to have him come on here for a second and explain that process and what he did. He's typing, ready to go. All right, I'm going to mute myself. You can come on.
Hello everyone, this is Sonu. Can you hear me? Please type if yes.
Yes.
We can hear you.
Okay, so this concept basically come to me when we were trying to just get all the annotation data. So we were having we were needed some space, some place where we can store all our data so that everyone can easily use this. Firstly, we can also see that upload portion in the Jupyter, but this was actually it's temporary time if we are using, and somehow if it's actually going to be format, then you will not be able to get that data. So here in storage that you can see on the screen, Devin is sharing right now. So here I created the button, and you can see that create bucket option in the screen. So basically I created a bucket, and here in the bucket you can upload your data from your local machine. Like I have firstly I have started with the train data and test data. So I uploaded all my test data and train data, and every person of the object detection team that did the same thing. So here the advantage, our advantage was this: everyone was able to get this data in their Jupyter workflow by using GS util. So it's actually the beneficial for us. Actually, I was thinking about this, that if we can access this storage by using GS util, somehow we will also be able to use this data to we can just like we are first of all our task was to create CSV from the XMLs that we are having in the train and test. So actually here in the train data, train image. So if we are just copy the data from bucket using GS util, then there should be something that can help us to actually read this bucket and read all the files and create a CSV. So I'm working on that too. And there is a Python library by the Google to access the this bucket. So I think somehow we will be able to use this by writing some script and using those libraries. So this was all I was work on. So it's all everything. It is about the bucket I have read till now. Thank you. Thank you, Devon.
Yeah, thank you. That was good. Yeah, so that was definitely very helpful. And thanks to Sonu for setting that up for us. We were able to share all our annotated data as well as any scripts and stuff that we wrote. So next up, we were creating the TF records. We had an XML file. Let me make this folder. So I wasn't very experienced with XML before this, but this is kind of the format. We parsed through that and pulled out the important stuff: file name, width and height, and then our class. Where's that? Is the name here? So this one's an auto. And then these are the points of the box, and we just needed to extract the X-min, Y-min, X-max, and Y-max values, and then we used another script to create the TF record. So the process, we used some modified scripts from open source object detection projects, mostly the Raccoon detection project, and Centdex did a project as well. And then some lessons we learned from that. The first time that we did the conversion to CSV, it was only pulling the first annotation from each image. So we only had about 1,300 annotations, and after the correction, we had all the annotations from the image, so it ended up being about 8,000 different rows there. So very important that you make sure your script is doing what you want, because we were working with a lot less data than we actually had before. We had a lot of errors modifying the scripts. They weren't working in the same environments, especially Windows versus Unix environments. So that can be an issue. And then, like I just said, verify that it's getting the resulting output, because we went a few days with a lot less data than we actually had. So next step, we got our virtual machine ready for TensorFlow, installed Anaconda, prepared the GPU, installed our TensorFlow environment, configured Jupyter, copied everything like Sony was talking about into the instance, prepared the data, installed object detection, generated TF records, and then copied those records into models, research object detection, so we could start training our model. And so I also wrote this up, just explaining kind of the commands that I ran to do all that, which has been shared. So if you need that, that's a resource. So we use what's called transfer learning. You have two options. We can train from scratch or use transfer learning. Transfer learning allows for faster training of the model because it doesn't start with randomly initialized weights. It's using weights based on a pre-trained model. So that's the direction we went. It's very difficult and time consuming to train your own model from scratch. So it's if there's been similar models created, it's easier to use the transfer learning and take what their model has already learned a bit and then apply it to your new data. So here's kind of our TensorFlow. Here's the loss graph. It was decreasing, still decreasing after about I think over 8 hours. But we're really not going below 3, and we would like it to be below 1 here. So we'll talk about how we can improve that. So here's our model applied to a clip of our first video. Yeah, not great a lot of times identifying cars as trucks and things like that, but what it is able to do is detect motorbikes, which were not something we could use just using a pre-trained model. Autos as well. But as we go through, you'll kind of, that one saw the bus, but buses and trucks and things like that, we just had a lot less data points on, so it's not as accurate as detecting cars and motorbikes. And then at times, it just seems to not be detecting. It will detect something, and then it won't detect it a little later. So, thanks all. But yeah, I'll let this run a little bit longer. We can just kind of see. But another thing that's good is it is identifying some of this oncoming traffic, which is blocked by this wall here. So that's kind of some stuff we were initially concerned about, was if there's something blocking, would we be able to detect it? And it's not great yet, but it is detecting some of that stuff. So that's pretty good. But yeah, here I just think it's strange. It's not always detecting like a motorbike right in front. So obviously, still needs some work there. So I'll go ahead and stop that for now. So next, we had a second video, and I just took some random images from there. I just on my local system, it was difficult to run it on the video, and I wasn't able to the instance. So, but you can see here, it does detect autos, which is good, something we wanted to do. Detected a car, and then a truck that's being blocked by this car. But then it also detected this pile of dirt as a car. So not perfect yet. We got trucks, motorbikes. I think it's saying that's a truck, which it's not, but yeah, car, motorbike, and then you can see kind of where we still need some work. It's saying this row motorbike says truck. But I mean, I guess multiple wheels and stuff like that is confusing it, so probably just more data. So as I've kind of identified positives, it's able to identify motorbikes and autos, things that we'll see on Indian roads. It's best at identifying cars, motorbikes, pretty good at people as well. And we had more of our data annotated with those than we did things like buses and trucks. And also we're able to identify objects that are occluded, that are being blocked partially by something. Needs work. We want it to consistently identify all objects, and we need more data on buses, trucks, and autos. So suggestions for improving: more data will be better, especially there's lots of motorbikes and cars on the road, so that's easy to get, but trucks, buses, other rare vehicles are going to be something we're going to need to specifically maybe seek out and try and get data for that. So that will be better for a model. We talked about creating some artificial data, maybe manipulating the data we already have to do something like that. Sona, do you want to talk about the gamma correction for just a second? All right, yeah, go ahead whenever you're ready.
Yeah, of course. From last presentation, I saw Olaf applying all the gamma correction thing. So I thought if we could apply on our data and so that there will be the objects on the same location, and the difference between the current image and after applying the gamma correction, we will have the only difference between the brightness of the image. So I think it will not affect the XML structure of that that image, and we will. I'm also planning to check apply a gamma correction on a image, and then annotate it in the label wing, and same we can use to match. We are going to match it with the previous image XML and this image that will be generated by after gamma correction. So if there is not difference in the XML structure, so I think we can use that image also on which we are applying gamma correction. It's actually, I'm thinking right now, it's not sure it will work or not.
And having said that, we have also option of applying data augmentation, where we can actually change their height, change their blur of the image, and and all those intentions and intensity, and by which we can increase the number. Even though we have large amount of, like, we have 10,000 image data set, but yeah, we can apply gamma correction and then data augmentation.
Yeah, actually, for now, I was thinking if we can, we will get a lot of data after if we are applying gamma correction, then it's actually be easy for us to collect a lot of data from. Actually, we are having around 4,000 or something images. So if we are, suppose that we are going for 3 times, it was 2 times, take 2 times, one for evening and one for night too. So there will be the position of the object position will be same in all the images. The difference between only in the brightness, so it won't affect the XML structure. So I think we will have a lot of data, and hope it will. I think so. It will increase the training set, and our model will be more efficient.
Yes,
we can just try this.
Yes, so you're right. So similarly, there's something called data augmentation, where you actually change their height, rotation of those images, and by which also we can increase the data size. So that was only one of suggestion part from my side. Yeah.
Okay, we can try also that.
Sure.
Our data size will be increased. Actually, we just want to do that annotation part less, so we can have more time for that training purpose and all the things.
Sure. Yeah. Thank you.
Yeah. So that we'll try